Seems like I start every lecture with that. Okay, so we're going to continue with section 6.5, evaluating definite integrals. This is from our calculus by Sue Tan. We covered the properties of the definite integral last time. We did from the book, we did a couple of them. Let's just kind of review them. So if we let f and g be integrable functions, and for us, all continuous functions on a closed domain is integrable. So then the first property we have is that if we have the integral from a to a of some function f, that's equal to 0, because basically we're integrating on a line. So just a. And the area of a line is 0, so that's for that property. For number 2, that if I have the integral from a to b of f of x dx, if I change the order of the limits, so I go from b to a instead, what that essentially does is that it flips the value, so it becomes a negative. Number 3, again, if I'm integrating from a to b of f at x, and I have some constant c dx, that I can pull that c out in front. And this same property applies for the indefinite integrals. And similarly, if I have an indefinite integral, if I have the integral of the sum of two functions, that's just equal to the individual integrals. And that works for the plus and also for the minus, so you'll also see it written like that. And lastly, you can break up the definite integral. So if I was integrating from a to c of f at x, I can break that up, that I can integrate from a to b plus the area from b to c. And again, this is provided that a is less than b is less than c. So these are kind of the 5 properties that we'll be using for the definite integral. Let's do a quick example. So just as kind of a recall of what we've done so far with the indefinite integral, or sorry, the definite integral. So let's say we want to calculate what this value is, the integral from 0 to 2 of x squared plus 1 dx. Okay, and using, let's see, property 4, I can break this up. So I can do the integral from 0 to 2 of x squared dx plus the integral of 0 to 2 of 1 dx. Now, some people, if you're writing out solutions, or if I was writing out solutions, I wouldn't even bother writing out the 1, because the 1 is always kind of implicitly there. So you would have maybe seen me even write something like that. Just integral from 0 to 2 of dx. Okay, so we can integrate this quickly. The integral of x squared is 1/3 x cubed. It goes up a degree from 0 to 2 plus. And I have my integral of 1. So that goes up a degree, so that's x, and that goes from 0 to 2. And now we just substitute in our values. We use our upper limit first. So we have 1/3 times 2 cubed minus 1/3 0 cubed. Okay, plus I have x, so again 2, so the 2 goes in the x, so I get 2 minus 0. 2 cubed is 8 over 3. This is cancelled because I have 0 cubed, which is still 0, plus 2 minus 0, and writing this over a common denominator. 3 times 2 is 6. 8 plus 6 gives me 14 over 3. Okay, so this is just kind of recalling how to kind of do the definite integral again. Nothing fancy that we had to do without. There was no substitution that we had to do. This was fairly straightforward. Okay. So we can also do some other integrals without having to do very much calculation. So we've done that one. So we can say this is kind of A. Now we could do B. For instance, if someone said, oh, give me the integral of 2 to 2 of x squared plus 1 dx. Well, immediately, I don't actually have to do anything because I see my limit is from 2 to 2, which means that by property 1, it's equal to 0, because it's just a line that, and the area of a line is 0. Now, the next thing that we can do is, let's do the integral from 2 to 0 of x squared plus 1 dx. Okay, so I've already done this one in A from 0 to 2, but now I've flipped it. I've gone from 2 to 0. And that means by property 2 that if I flip it, that I get a negative in front. So again, I've flipped it, so that means that it's equal to minus 0 to 2 of x squared plus 1 dx. And I've already calculated what that is, so it's minus whatever the answer was for here, which was minus 14 over 3. So these are quick. What else? What else? What else? What else? Let's do D. Okay. Let's say I'm going to integrate from 0 to 2 of 10x squared plus n dx. And that equals what? Now, again, I'm trying to use what I've done already in A. In the way, again, problem solving, we're always trying to break it back down to a problem that we've already solved. Again, mathematicians are lazy. So, the trick to this is we factor out the 10. So, we have a 10. I can factor that out so that I'm left with x squared plus 1 dx. Perfect. Still not what we have up top here, but using property 3, I can actually pull out a constant in front of the definite integral. So again here, this one just boop, comes out in front. So I can do that. So that brings my 10 out in front, going from 0 to 2 of x squared plus 1 dx. And I need to use what I originally did in A. So that's equal to 10 times 14 over 3. And that is equal to 140 over 3. So, for instance, problems that we could be asking, say on I don't know, an exam that's upcoming, looking at things like from 0 to 2 of f at x dx is equal to, so we can start to generalize, and you might not know what f is. We will just tell you that f is integrable, so we can do the integral of that, and we can tell you, say, it's 14 over 3. And then we can start to ask you things like, okay, well, what is 2 of 2 of f at x dx? That's equal to 0. And again, you'll be able to do something like that, which is minus 14 over 3. So again, you're seeing that an online calculator or an online integrable or integrator is not going to help you with this, because we could write you a question similar to that where you don't know what the function is. You're going to have to figure that out yourself. So you need to know these concepts. And same thing here. If I was to change it, I would go from 0 to 2 of 10 f at x dx. And again, you would see that this is a little bit more clear. That's already factored out. You can pull that 10 out in front. And again, 10 times 40 over 3 gives me 140 over 3. Okay. So would you be looking for an answer like this on the exam where we write out the negative version thereof? That's a good question. It depends on the format of the question. Questions like these, I think, are more suited for multiple choice style questions. And in that case, you wouldn't really have to show very much work for it. It's just a final answer. If you were having to write this out and this is going to be something that's going to be submitted, then yeah, we would like to see some work. And I would say show enough work that's appropriate for the number of marks that's indicated in the right-hand margin. So if there's only like 1 mark, really there's not too much writing that you should be doing, or like a final answer. If there's like 2 or 3 marks, there's 2 or 3 things that I'm kind of looking for. So again, that's giving you a hint of what we're looking for. Do we have any quizzes before the exam? I'm looking into it. I'm trying to see if we can get something to work. I'm looking at other avenues. I'm looking at Moodle. I'm looking at some other testing stuff. So the answer again is I'm looking into it, and we're moving as quickly as possible. I'm also getting a lot of emails about exams. Again, the exams schedule hasn't been finalized yet. They haven't emailed anything out, and you're more than likely to know probably either before or exactly the same time that I know it as well. So, but I believe the exams, according to the Commandant, is happening in the 3rd week of April. So again, it's not going to be this week that it's happening or the next week. It's the 3rd week. Let me check. 1, 2, 3. Okay, I meant 4th week. because this week is still classes. We still have classes next week until the 17th. I plan to not have a class on the 10th of April because that's Good Friday, and we also have a class we had a class scheduled on the 13th, but I will also probably not have a class on Easter Monday on the 13th of April. And we'll have, so the 9th, the 16th, and the 17th. I'll probably jam in some extra tutorial time in there to make up some of the Friday and the Monday classes missed. We'll turn that into tutorial, something like on Tuesday I'll have like, I don't know, a 2-3 hour extravaganza of you listening to my voice. I'm sorry, that is, even I kind of get tired of my own voice. So, yes, I'll try. We'll do as much work as we can. Yeah, and YouTube seems to be holding up okay. Okay, so with some of the administration out of the way, let's try some other examples. Yeah. No, I think YouTube will stay up. Okay. Example. Let's say we're given that the integral from 6 to minus 10 of f at x dx is equal to 23. And we'll say that the integral from minus 10 to 6 of g of x dx is equal to minus 9. And then they go, what is the value of minus 10 to 6 of 2 of f at x minus 10 g of x dx. Okay. So if I integrate this, and these questions are great because you actually don't have to really integrate, it's just applying some rules. So again, using property 4, if I have the sum of two functions, it's equal to the integral of the individual functions. So again, I can break this up. So I have from minus 10 to 6 of 2f at x dx. I'm going to use plus for a moment. Okay. So again, using my property 4, I can do that. And then using the third property, again, I can pull the constant out. So I have 2 from 10 to 6 of f at x dx. And again, I can pull that minus 10 out. Okay. And I've reduced it down to data that I already have. So 2 times 23 minus 10 times minus 9. 23. Oh, and oh, I can't do it yet. And the reason for that is because I haven't replaced this yet. See, because I have from minus 10 to 6, and instead I have from 6 to minus 10. So what I have to do is I have to flip it. So this part here, I can flip that, so I can go from minus 10 to 6 of f at x dx. And that's equal to minus 23. And this is by using our rule here, which was number 2. If I change the order of the limits, then it becomes negative. And that's what I've done here. So minus 23. So now I have the minus 10 to 6. So now I can do 2 times minus 23 minus 10 times minus 9. So I have minus, and 2 times 3 is 6, 2 times 2 is 4, and then positive 90. And 90 minus 46 leaves me with 44. Okay, good. And it's showing up on the screen. Good. And this is the final answer for that. So be very careful, because on a multiple choice type question, you're probably going to see an answer where I almost calculated it with a positive 23. So it would have been 96 plus 40, 96 plus 46, so 102. So you could have seen an answer like that, 102, and you would have selected that and that would have been wrong. So careful. Okay. So that's done. Let's do another example. So we're given from 0 to 3 of f at x dx is equal to 9. We have from 3 to 4 if f at x dx is equal to 8. And from 4 to 6 of f at x dx is equal to 7. Then they ask, what is the value of from 0 to 6 of f at x dx? Now, just kind of intuitively, if I have some function like this, spread it out. So up to that point, say 3. This area is 9. Up to, say, area 4. There we go. We have this area. Here's 8. And then from, let's do a different color. From 4 to 6. Here's 7. And then it's asking me what's the value from 0 to 6. And so quickly, you know, you just add them up. So 9 plus 8 plus 7. So 9 plus 8 is 17, plus 7 gives me 24. But, you know, if you were asked to show that, so like again, if it was multiple choice, boom, that's quick. Or you're asked to kind of show this. Again, that's equal from 0 to 3, plus from 3 to 4, plus from 4 to 6. Again, that's 9 plus 8 plus 7, and that's equal to 24. And this is an extension of property 4. So again, if I had 3 functions, I can break them up. So if I had f plus g plus h, the integral of that's equal to the integral of f plus the integral of g plus the integral of h. So that's what we've done here. Okay, so we've done that. Okay. I had a little bit more complex of a example, but I don't think that is necessary. I think everyone understands this. I don't think I need to complicate it and make it any more complex than necessary. Okay. So I'm going to just kind of illustrate something from section 6.7, and this was kind of like more from the application section. And this is from economics. So for instance, let's see. We're used to seeing, before we saw demand curves. So here is something like a demand curve. And the other corresponding one that we have is a supply curve. So we'll look at a supply curve. So here we go. And I have something like this, something increasing, and this is x. So x is the number of units produced or supplied. Maybe I should put that. So this is the quantity supplied. There's there's x, and then there's p. And p is it's something called like the unit market price. So per unit, how much it's being charged by the supplier. And this is called the supply curve. Okay, so usually the supplier will set the price. So for instance, he'll say, we'll set the price at X bar. So here it is. And then that corresponds to a price that he should set. Now there's something called the supplier surplus. And that supplier surplus, okay, so this is all the stuff that's being bought by the consumer. So in here is the consumer, I believe that's called the consumer demand, or the consumer consumption, or whatever. And the consumer, or the supplier surplus, is in here. This is the stuff that isn't sold. So it's this area in here that's called the supplier surplus. Now, how do we calculate that? Already, that's an area. We have to calculate that area. How do we calculate that? We have to use another problem-solving technique. And we'll call it indirect reasoning or indirect method, because what we need to do is we can't calculate this directly, just kind of like using just one integral. We have to do some steps to get to that. So we need this area, but to get to that area, what I'll do we'll calculate this area, this entire area. Okay, and that area is easy for us to calculate because it's just a square or a rectangle. And the area of that rectangle is the width times the height. So that area is equal to P bar, which is the price that is set, and X, which is the number of units that are supplied. So the area of this is P bar times Px. And then what I need to do is I need to subtract something from this total area here. So what I'll do is I can easily calculate something. I could calculate here's P bar and here's X. So I want to be able to subtract this area here, because that's the stuff that's sold. And this curve so now we have to write an integral for this area, and that area is from 0 to x bar of the function, the supply function, so s of x, and we're integrating with respect to dx, so that's it. And when we do that, that means I have all this area, and then I kind of remove this part here, so that should leave me with just this area right here. So therefore, the supplier's surplus is equal to the price that the supplier sets times the quantity that the supplier is supplied, and then we subtract what the consumer has bought, and that goes from 0 to x bar, and we're integrating over that supply curve dx. Okay, so now what we'll do is we'll do an example of that, with numbers or with an actual function. So here's an example. We have the supplier of graphics cards and will make X hundreds of cards available in the market when the wholesale unit price is and they do P, of course this is S of x. So P is equal to 36 plus 1.8x. This is in dollars. So what we have to do is determine the producer's surplus if the wholesale market price is set at, say, $9 per card. Okay, so immediately we know that the price is set for the card by the supplier. So they said that P has to equal $9. So P equals 9. Then the next thing that we need to figure out in our formula is that we need to figure out what x bar is. And to figure out what x bar is, I need to solve for x in this case. So I know what P is, so I'm going to say that this is, I have 9 equals the square root of 36 plus 1.8x. Then what I'm going to do is square both sides so that 9 squared becomes 81. And the square root disappears, so I'm left with 36 plus 1.8x. Then I have the 36 come over to the left-hand side, so I have 81 minus 36 is equal to 1.8x. 81 minus 36 is 45. So I'm left with 1.8x. And dividing 45 by 1.8 leaves me with 25, I think. I'll double check. 45, 1.8 is 25. Okay, so my supply surplus formula then, or the producer's surplus, that is equal to P bar, which is 9, times 25. Oh, I should have. Okay. And then I need a minus, and now we're going to go from 0 to x bar. In this case, it's from 0 to 25 of the square root 36 plus 1.8x dx. Uh-oh. There we go. So there it is. Oh, thank you. Yes, I'm writing off the screen. Thank you. Okay. So I have that. Make sure that I have enough room. Move this up here. So there's my formula that I need to solve. The 9 times 25 is easy, but it's the integral here from 0 to 25. That one is a little hard for us. So again, we're going to use an indefinite integral first, and what we're going to use is substitution. So using our substitution rule, I'm going to let all that inside stuff be u. So let 36 plus 1.8x. And now if I differentiate that, I get du is equal to 36. Remember, I'm doing a derivative now, so 36, derivative of 36 is 0, and the derivative of 1.8x is just 1.8 dx. Bringing the 1.8 over to the left-hand side, because I want to replace this dx. So that dx here becomes 1 over 1.8 du, and this square root of 36 plus 1.8x becomes u to the 1/2. Okay. I can bring that 1.8 out in front. Okay. And then I'll integrate this. So again, 1/2 plus 1, it needs to go up by 1. So that again is equal to 3/2. So that's what it is in the exponent. So 1/2 going up by 1 gives me 3/2. And then in the denominator, it's going to be 1 over 3 over 2. And I can bring that 2 up into the numerator. You can also think of it as 3 times 2 to the minus 1, and get rid of that negative 1 in the exponent. 3 over 2, I get is equal to 2 over 3. And I'm almost done. I have the u to replace. So I get 1 over 1.8 times 2 over 3 times 36 plus 1.8x to the 3/2 plus a constant. So therefore the producer surplus is 9 times 5 minus 1 over 1.8 2 to 2 over 3 times 36 plus 1.8x times 3/2 from 0 to 25. Okay. These are not great numbers to work with because I got 3/2 and I'm going to be shoving this into with 25. So I'm not going to lie, I used a calculator. So that's for this part. Again, if it was on an exam and you didn't have to use a calculator, the numbers would be nicer. Oh, crap. All right. 9 times 25. So 9 quarters. That's $2.25. And then I need to do a minus. I'm going to multiply that together. So I got 2, so that's equal to 2 over, so 5.4. To get a 0 on the bottom, I need to multiply that by 5. So 5 times 4 would give me 20. So okay. And then again, I'm just you substitute in these values now, so I get 36 plus 1.8 times 25 to the 3 halves minus, and I have to calculate this for 0 as well, so I got 10 halves over 27, 10 over 27 times 36 plus 1.8 times 0, all to the 3 halves. So that reduces. Okay, this is where I'll pull out the calculator. I have 36, and I have 1.8 times 25, plus, it's 81, and then I need it cubed, which is quite a large number. Square root gives me 729, plus, it's going to be minus 36 cubed. Gives me 46,656, and I need to square root that. Gives me 216. So 10 over 27 times 216. So I have 729 times 10 divided by 27 gives me 270. And then I have 216 times 10 divided by 27 gives me 80. We subtract that. That gives me 190. I have 225, and then I subtract that. Gives me 35. So we're not quite finished yet, because the question says, determine the producer surplus if the wholesale market price is set at $9 per cart. Now, the surplus is 35, but that's according to this equation. We have to be very careful because it says X is in hundreds of carts. So therefore, the producer's surplus is 3,500 cards. So again, I'm not sure if something like that was presented in the economics class yet, because again, it kind of relies on integrals, but again, there's something very useful to integration. We're again reducing it down to finding an area, and we had a very simple problem of calculating what the area is, and that corresponds to, there's an interpretation for economics, which is that's how much left over that the supplier has. So they fix the number of quantities supplied, they fix the price, and this is what's sold, this is what is left over. So we can actually come up with a formula for that, and we solve this. This is called indirect reasoning, or an indirect method. And again, we're not calculating that area directly, we're using some other information to kind of figure it out. So we've covered some interesting things. We covered actually 2 problem-solving strategies today, which was reducing a problem back to something that we already know how to solve, or it's reducing it to something that we could easily calculate. And so in this case, given that we spent all that time calculating this integral, we were able to solve a couple other integrals using that same information. And in this case, we were able to use indirect reasoning. The other thing too, when we're doing problem solving stuff, drawing up, I find it's very helpful to draw a diagram. And it helps to illustrate visually what you're doing. And if it's not making sense what you're doing visually, it's probably not going to make sense what you're doing mathematically. Again, you don't have to memorize that. This was just an application of the definite integral, and also to answer a question of why are we learning this, and is this going to be useful? And the answer is probably it's going to be useful in higher up classes. Okay, we have done it before when calculating the producer surplus with 1/2 b times h, because it was a triangle. Okay, yes, that would make sense. So again, if you had something simple where you didn't have a nice curve, or you had a nice curve, you were saying something along the lines of this. Probably was just at this point a straight line. So here's my p, here's as at x, here's p. Yeah, so this would be what the customers had bought, and this would be what the supplier surplus would be. So yeah, this would be a very easy case if it's just a straight line, and yes, you would just calculate this area right here. Okay. Do I have other questions? Any other questions that you have before we sign off today? Relating to the material. I don't have an oracle yet. I wish I could tell you the answers for everything involving what the registrar is doing. But again, there's lots of things that are in discussion. Okay, if there's no more questions, you have my email address. Lots of you have been emailing me. That's very good. Make sure if you are sending me questions or there's concerns, yes, I will answer them through email. I'll try to respond as quickly as possible. And I hope to see you all on Thursday when we meet again here on YouTube from 8 a.m. to 10 a.m. Eastern Standard Time. Okay, enjoy the rest of the day. Take care.